Hi everyone, in this video series we're going to go over how to use the Langmuir Systems touch probe on the MR-1 CNC milling machine. In the first part of this video we're going to cover what comes in the touch probe kit. We're going to show you guys how to get that set up on the machine, how to get it hooked up to the electronics box. We're going to review some of the probing cycle routines that we have built into cut control, and then we're going to give you guys a couple examples of using these touch probe routines on the machine. So the first thing we're going to do is we're going to cover what comes in the touch probe kit. You've got three things. The first is going to be the touch probe itself. It looks like this. It's got a stylus tip on it, and you'll notice you can move it around like this. That triggers the probe. It has a 3/8 shaft on it. It gets installed into the spindle using the included 3/8 collet that came with your machine kit. The other end has this 3-pin aviation connector. We'll plug this into the extension cable that gets installed into the machine, and it lives there permanently. And that's this cable right here. This has a male connection and a female connection on two opposite ends. And essentially what you do is you come to the MR-1 spindle cover. There's 3 holes in the top here, and we give you guys a plastic P-clamp and then a screw for threading into plastic. And you take this end here and you're going to affix it using the P-clamp. It's just going to kind of live dangled off to the side. The other end you're going to run through the loom. It follows all of your spindle and Z stepper motor cables up the cable support tube, and then if you've got the enclosure it'll go out the grommet like the other cables. Otherwise it's just going to go down, and then you will plug this end into the electronics box on the side. And you'll plug that into the touch probe port. So that covers everything that comes in the box. So what we're going to do is we're going to get our extension cable installed onto the machine. We'll put the P-clamp on and we'll get that sitting up there. And then we'll also get our probe mounted into the spindle. So with the 3/8 collet, you're just going to put that up in there. And then this cable, whenever you do use the probe, you're going to make that quick connection. And then when you're done with the probe, you're going to pull it and you can set it off to the side. So we're going to go ahead and get this set up, and then we'll move on to the next step, which is dialing in the run out of the tip. Okay, so now that we have our probe installed into the spindle, we've got all of our cables managed. Again, we've got this quick connect just sort of dangled off to the side here. That way, anytime I want to run my probe, throw it into the spindle, make this connection. And so what we have here is sort of the first thing you're going to want to do before you run your probe. Now, we assemble these in our factory. We do some QC on them. What we don't do, and this is going to be particular for your spindle and your probe, is setting the run out of this tip. Essentially what we want is we want the tip of this probe to be true to this running axis of this spindle. So in order to do that, to really get this dialed in right, you're going to need a dial test indicator, preferably on a magnetic base like what I have here. You know, just hook it up to something that's magnetic, like a steel vise. And then you're going to want to indicate the tip of the ball here. And you'll notice that along this flange, there's going to be 4 stainless set screws around here at the 12 o'clock, 3 o'clock, 6 o'clock, and 9 o'clock positions. We just have them loosely installed during assembly, and what you're going to do is, once you've got your indicator here, you're going to use these set screws to essentially center this probe tip relative to the center of my spindle. Now, I'm not going to show you the process to do this. It's a very iterative process. You're going to move a set screw, read the indicator, then you're going to flip it 180 degrees to the opposite side and check the position there. And really the easiest way to do this is just focus on one axis at a time. So this set screw and the opposite set screw. Don't worry about what the indicator is reading as I rotate it from here to there. Just read the difference between those two measurements. Whatever that is, find the average of them and then adjust one side so that I get right in the middle of that average. And then I can now flip to the other side and then do it in that angle. So once you kind of do this a couple times, you'll see here I've got maybe, I don't know, a couple tenths of run out here if I spin. So that's pretty good. I'm happy with that. I think, as long as you're shooting for somewhere around 5/10 of run out of your probe tip, you're going to be able to make some really accurate probing moves. So with that said, I'm going to pull the indicator away, and we're going to kind of look at some of the menus in cut control. The first thing you want to do is come over to the left in cut control, and we've got right at the top here on the left side, we have a touch probe module. If you followed along our tool setter series, it's very similar. It's just going to have this toggle, and it'll pull down here. You'll notice in this drop down, we've got some various touch probing canned cycle routines here. And we're going to, in this video series, show you basically how to use each one of these and what the settings mean. But for now, we're just going to focus on a couple things here. And probably the most important is this test button. Really important, whenever you're doing any probing, we want to make sure of a couple things. One, that our probe works, and two, that it's plugged into the box, it's into the right port, and it's communicating with the controller correctly. If that doesn't happen, you could be doing a probing move here, and you don't want, the last thing you want to do is crash your probe. So what you're going to do is hit this test button. It's going to turn red like this, and you'll notice down in here that I'm going to have a grayed out probe icon. And all I'm going to do with one hand while looking at this is I'm just going to trigger my probe. I just want to make sure that is, every time I flick that, I get an indication. And I can flick it in a few different areas, just make sure it's working. Obviously, I've got this LED illuminating here whenever I flick it. So I know my probe is working, no issues there. The next thing that I'm going to do is I can open up the settings menu. We'll cover the specific settings here as they relate to the various probing routines. In general, I'd recommend just running the defaults. So, every time you run up, just hit reset. That'll basically reset all the defaults here. And what we're going to do now is we're going to do just a basic single axis probing routine. So coming back into the touch probe module, what I'm going to do is just do an x-axis probe routine. And what all this is doing is it's just going to move the machine in the x direction, either this way or this way, and touch off of a feature. And it's going to basically set the spindle center line to that feature. So I'm going to just kind of jog over here, show you guys a quick demonstration. So I can jog next to the part. Now, when it comes to depth, how deep do I want my probe next to the feature? Now, do I want it all the way down here? No, if I can avoid that, I don't want to do that. As this probe hits, I don't want my shaft interfering with that. It should still probe okay, it's just I'd prefer to avoid that. If I've got a nice clean sidewall, I'm probably going to come like maybe one diameter of the ball tip down. And in terms of how far off do I want it, that's called the seek distance. So if I come into our settings here, I can see that the seek distance is set to 2 inches. That's the default. Now, if I try and do this probing routine and I'm more than 2 inches out of this wall, and I'm going to be probing, looking at the icon, I'm coming in the left direction, and I start this routine, it's going to do its thing, it's going to move, and if it doesn't sense anything within that 2 inches, I'm going to get an error. And here we go, I've got an alarm, basically was not triggered within the travel limit. Okay, so I'm going to clear that. Now let me show you guys what it actually should do. So we'll come over to here, looking in our general settings, retract distance. So these general settings are going to apply to the single axis probing routines. So retract distance, that's basically after it touches my material, how far is it going to retract off? So if I come in this direction and I probe and it does the routine, how far am I going to come off? Similarly in Z, if I come down and touch off, how far am I going to pop off? Highly recommend just leaving it at the default unless maybe you're probing something way up here in Z and you don't have enough retract distance before you hit the limit switch, then maybe you want to come in and mess with that. Seek rate, I've got it set to 15 inches a minute. That's the default. We really don't want to be running our probe in at full rapid. There's really nothing to be gained by doing that. And then my seek distance, as we saw before, is set to 2 inches. That's all default as well. So let's just go ahead and we'll do this move here. Again, it's going to move in. It's going to indicate the surface with the probe, and then it should set the center line of this probe tip to that edge. So we're going to go ahead and run this now. I'll hit start routine. All right, I'm going to run that again just so you guys can see. It does happen pretty quick. Okay, so now what does this mean? Let me jog up a little bit. I'm just gonna come to my Y0 position, and we'll look. I'm sorry, X0, and we'll just look at this probe tip. And there we are. We should be centered right over the edge, exactly where we want it to be, and it is. And so we know we found our position there. Similarly, we can do, you know, if I wanted my origin to be, my XY origin to be, this is in Y, the one I just did is in X, that would set my origin right here. I can just come over and do that exact same thing. And I can come in, you know, and just move in the positive Y direction. So I'll say positive Y, start routine, and there it is. So now it has zeroed my Y position. And now if I hit go to XY0, it's going to put me back there. Again, I probably should have brought the probe up. I'm lucky I didn't hit anything, but that's the general idea. Similarly, I could go to single axis in Z, and I could come and touch down this surface. So that covers just single axis probing with the probe. All right, so now that we've covered single axis probing, we've gone in the X direction, the Y direction, Z direction. That's just quick and convenient if you want to walk up to the side of a feature and just touch off right there and set your zero quick. Now there's actually a faster way to do what's probably the most common, which is setting your X, Y, Z all in one shot. And so what I mean by that is when you're milling, it's very common to have a part or a piece of stock where I've got just a rectangular corner. And a lot of times my origin will just be right at the center of that corner, and my Z0 will be at the top of the part. So basically what I want to do is, with one press of a button, go find my zero in the X direction, the Y direction, and Z, and basically just set my origin right at that corner. And to do that, in cut control, the routine here is called corner probing, in parentheses, XYZ. And a couple things you'll notice here is I've got kind of a bird's eye view of what I'm looking at. I mentioned I'm trying to find the corner of that stock, so I could basically tell cut control which corner I want. So in looking at my block here, just to show you guys on camera, I'm just gonna set this corner right here to my XYZ coordinate 0. So I'll come over to here and I'll hit the corresponding front right button. That'll highlight what I want here. Now we have this thing called bounding box, and it's set to 1 inch. Now what is that? So with corner probing, essentially what I want to do is I need to position the probe within an imaginary bounding box on this corner inside of the part. So if I have a 1 inch bounding box, that means that 1 inch this way, 1 inch this way, and then 1 inch up. Imagine just an imaginary box here. If I stick my probe anywhere in this imaginary box, I can go find this corner. Now, why is that important? If I've got a feature where I don't have stock here to fit within that kind of just default 1 inch bounding box, then that's going to be a problem. And if there's, let's say this corner were cut away and I needed to get in here and really the bounding box was smaller. Well, what I would have to do is come over into the settings menu. And for the probe routines, I have corner probe bounding box is 1 inch. So if I want to change that to something smaller, I can. For here, I know I've got 1 inch in real estate everywhere. I can just leave that. And I think that we have a representation visually here. If I click this eye, you'll see that bounding box is represented by that imaginary red. That's where you want to kind of stick the probe within. So I know for this part, I'm going to be good. The only other setting that matters for this is going to be corner probe XY depth. The default is set to 0.15 inches. So what that is how deep is the probe going to come down and then move in along the XY? Now it's set to 0.15 because we know we've got surface down here. It's I don't want the probe going too deep. But if I had some feature where that was going to be a problem, I could go in there and I can make a change. But for now, we're just going to leave this here. And I'm going to position my probe sort of within this 1 inch imaginary box. I'm probably, I don't know, ½ inch or so inside of this. So I know this is going to work. and I'm in the front right, so I'm just going to hit start routine, and here we go. So it's going to do Z first, sets my Z, then it's going to come out and do the X, sets X, and then we'll come and set our Y0 here. All right, and then at the end of this, it's going to wrap it just right over to the origin position, and we're up a ½ inch, which is just our generic retract distance in our settings menu. So if I jog down here kind of slow, we can kind of just do a visual of how good did we do, right? So, you know, if we come in here, it says I'm 25 thousandths, that looks pretty good. I can just actually hit Z0, and there we are. We're just right on top of that corner. That looks perfect. So one of the common work streams when you're putting a piece of stock in there and you're just going to touch off, set your origin real quick, is you want to go and use the tool setter. And what I want to do is I just set my Z plane with the probe. If I put a tool in there, then the Z plane is useless because my tool is at just some arbitrary length. But if I've got my tool setter, I can come and now probe off of this, calibrate my offset value using the probe tip. So I can come over to my tool setter. Again, I'm going to hit the test button. Just haven't used this in a while. I'm indicating, I know I'm plugged in, so I'm good there. And I'm going to come down to this calibrate button, and I'm going to set the red indication light to probe. And I'm probably just going to jog a little bit up for clearance. I'm going to hit calibrate. It's going to make a move over to the tool setter, about 13 inches to the right, 10 inches towards me. That looks good. I'll hit continue. So this is just going to come right down and touch the tool setter here and give us that calibration value. So now if I go look over here, I've got this tool offset value. We can see that that's now changed. So all I would need to do to run this part, pull the probe out, put my tool in, hit auto tool set, and I can hit cycle start and I can go. So that's corner probing, and now we're going to get into finding the center of bores and finding the center of bosses. Okay, so the next probing routine that we're going to cover is bore probing. And what that is we're going to let the probe go find the center of a circular bore. Now, why would that be important? Well, sometimes I'm working on a part or a feature where I've got to go and do some additional operations maybe where it's extremely important that those features are referenced to the center line of something circular. Very common in machining. We know we've got this probe here. We know that it's very accurate. So what we can do is we can just use this probing routine. So coming over to the touch probe module, I'm going to select bore probing, and there's really no settings involved with this. What we really need to do is jog the probe tip down into the bore. You know, it helps to kind of pick a slower jog speed here. Get it so that the ball is fully submersed, let's call it, into the bore. I don't want it hanging halfway up. I need that ball kind of all the way in. And just anywhere in the center, doesn't matter, just anywhere inside this bore, preferably as much in the center as you can. We'll just probably make it more accurate, but just anywhere that I've got it like this where it's just sitting down in there. Then I'm going to come back to the cut control, and I'm going to hit start routine. And you're going to get the pop-up. It's basically going to just make sure that you've got it and you've got everything set. So we're going to go back to the part, and I can just hit continue here. And what we'll see is it's going to find the center in the X direction, go to 0, find the center in the Y direction, go to 0. So we're going to run this now. All right, so now that the routine is complete, we can come look at our DRO here, and we'll see that our work coordinate system for X and Y are both zeroed out. So we know that this probe is sitting right in the center of that bore. If you want to really convince yourself, just go ahead and run the routine again. You'll find that it's going to put it into the same position if you go into machine coordinates and use that as a reference. All right, so the last probing cycle we're going to cover within cut control is called boss probing. Similar to bore probing, what we're looking to do is finding the center of a feature. In this case, that's going to be a boss. So I've got a part in here that has just a boss, and what a boss is really is just a circular protrusion. So unlike a bore that's sitting down into a recess, this is basically sticking up. And I want to know, what is the center of this? So we've created a module within cut control that'll do that. I can just come into the drop-down menu, go to boss probing, and I've got a couple features that are exclusive to boss probing. And so what these are is, unlike bore probing where I could just put the probe down into the center, with boss probing I actually need to tell it roughly the size of this to within reasonable accuracy. And we'll cover what the buffer is there. There's a setting for that. But in looking at this, I know this is roughly 3/4 of an inch in diameter. So what I can do is I'll just type this in here, 0.75. I guess there's only one decimal place on that. That's okay, because within the settings, there's a feature within probe routines called boss diameter buffer. Now what this is basically, it gives you a little cushion on how inaccurate your estimate for the boss size can be. If you set this really large, yeah, you're not going to crush your probe, but you're going to be waiting a while because it's going to touch this side and then come all the way over and add that buffer and come back in here. So if you know your feature, it doesn't hurt to get a caliper out and measure it, and then use a reasonable buffer like a 1/2 inch. You're going to be really safe here. But just as a warning, whenever you do the boss probing, make sure that you set the estimated diameter. If you don't, you have a potential to crash your probe. Now, the next setting we have to set is probe retract. Now, the reason this is important is what it's going to do when I go and probe, when I probe a boss, is it's going to touch off always starting on the left side in the X direction. This is where I need to set my probe to start a boss routine. It's going to move along the X, touch that, and then it's going to retract up, come across, come down again to the same height as the starting height, what I have here, and then it's going to come in and touch this side. Then it's going to retract up again to that retract distance, come to center, and then do the same thing in the Y direction. So the reason that retract is important is, let's say that I have a boss that has a step in it. Let's say this boss was maybe a 3/4 deep, and on the bottom of it there's an even larger bore that I want to find the center of, because maybe this isn't circular or it's not something that I can actually probe. I need to make sure that when I touch off of that, I retract all the way up enough to come over and across. So for here, I know my boss is only about a 1/2 inch deep. I know I'm probably just going to start like right here. So I really only need to retract maybe a 1/2 inch to clear. So I'm just going to leave the probe retract set to a 1/2 inch. Now, in terms of probe positioning to start, I've kind of covered that. You just want to roughly get it in the center this way. It doesn't have to be perfect, but I don't want to come moving X starting down here. Eyeball it in the center here, and then always start it on the left side of the part, because we're going to make that first positive X move. And then in terms of depth, I don't even want to go super deep here. 1 ball diameter down is good, and I need to make sure that wherever I start, that retract distance that I put into the settings is enough to clear and come across to the other side. So I know where I'm sitting is good here. I'm going to hit start routine, and then we're going to watch it. So you'll notice it used that buffer distance and came out about a 1/2 inch extra from that estimated diameter. That's good, that's what we want. Now we're going to be doing the same thing in the Y direction. And again, I'm just showing for the tutorials, I got everything kind of set pretty slow here. And we recommend when you're new to running these routines, you're not really optimizing for any all-out cycle time here. Just kind of use reasonable feed speeds. I think we have 15 inches a minute for this cycle. So it's coming up, and then it's going to move back to 0. Okay, so now I know in my DRO, I know X and Y, I'm both at my 0 positions. If I jog down in here, I can see that I'm in the center. That's perfect. So now I can go ahead and put a tool in here and run my operation now that I'm set. So that covers boss probing. Thanks for watching.